And then we're going to answer some questions about this formula we found. And so it says use the exponential model, so that's this right here, to estimate the enrollment in 1965. So remember 65, this is when t equals 0, so you could just plug in 0 and get your answer, but it's actually just this first number, the initial value. So it starts off here 7.11, and we have million students. Again, is this close to the actual value? But again, it's more than a million off from the actual value if you look back at the table, which was 5.921 million students. So is it close? Is it not close? Again, it depends upon the context you're using this model and what you're going to do with it. All right. On the next page, it says use the exponential model to predict the yearly growth factor and percentage rate growth. All right, so if you look back, the growth factor is the number you're multiplying by, and that's that 1.024. So right here, I'd put the growth factor is equal to 1.024. And while the percentage rate of growth, right, so the percentage rate of growth is equal to, now you ignore the 1 because the 1 stands for the whole part, and you get us 0.024, and so that's 2.4%. Right, remember, the way you turn a decimal into a percent is you simply move it over 2 places. All right, now we're going to use both of these models to basically plug things in and solve, or set equal to and solve. So it says use both models to estimate the enrollment in colleges in 2010. So in 2010, we have to figure out what t is equal to. So it starts in 65, and so this would be t equals 45. And in the first one here, what we're going to do is we're going to plug in, right, e of 45, and you go back and you look, right, at your linear model, and you'll see that this is going to be equal to 0.2621 times 45, and then plus 6.9784, which is equal to, you take out your calculator and you crunch the number, and so on here I take 0.2621 times 45 plus 6.9784, and I get out my answer of 18.7729 million students. So there's my first one. And then on the other side, okay, I want to answer the same question. All right, so still t is going to be equal to 45. All right, so I have t here equal to 45, so I'm going to find e of 45, which was equal to, you can flip back, and it's 7.111 times 1.024, right, to the 45. And I can crunch this number on here, so 7.111 times 1.024 raised to the 45, and hit enter, and I get out my answer here of, this one I guess I'll round to 3 decimal places, so approximately 20.674, again, million students. Okay, and so now the next part, it's part L, it says the actual enrollment in 2010 was 20.675 million students. Which model is better in this case? All right, so the linear predicted this amount, the exponential predicted that amount. So which color works better, red or blue? Obviously the blue, and so we conclude, the exponential model was better. Exponential model was better. I guess we should write D here. All right, so the exponential model was better. So now this one was plug in for input. So last one should be plug in for output. And so we look on here, and the question says, use both models to estimate the year in which the student enrollment will reach 25 million. And so the idea, this is output stuff, it's not T stuff, so you plug 25 in for the output and for E, and set it equal to the formula, so 0.2621, and then we have a T here, and then plus 6.9784, and we want to solve this for T. Now there's two ways to do this. We can solve it by hand because it's a linear equation, or we can just use our calculator. I'm just going to use my calculator. So down here, what I'm going to do is I'm just going to plug in this, so 0.2621, and I have an X, plus a 6.9784. Right, hit the graph button. Oops, so that's wrong. Right, clear that out. I'm not supposed to put the formula. I already have the formula up there. Just put the number 25 there. Oh, so my bad. So go back, delete it out, just put 25 there. Now hit the graph button and see what happens. Okay. I did not see a horizontal line go through my picture. The reason I did not see one is because the window is too small. So I got to make my window bigger. So I'm going to go from, let's go from 0 here. And let's go to, let's say, 100, right, for 100 years. And then zoom fit, and see what happens. All right, so there's my line. There's my exponential function, and there's the horizontal line, right there, and it crosses the line. And so what I can do is hit second, trace, go down to intersect, and here I have to be careful, okay? First curve, yes, I want to be on the line, so I hit enter. Now second curve, I do not want to be on the exponential function, I want to be on 25, so I'll hit down, and that takes me to 25. Yep, that's my second curve. Hit enter again, and out pops my answer. So on this one, T was approximately, let's say, about 68.8 years. And it says in what year, so I'm going to add 1965 to it. All right, so I can clear the screen and take 68.8 plus 1965. And I get, oops, I don't want that. So 2633 is way too far out. I had an extra 6 there, so delete that 6. Okay, there it is in 2033. That seems better. So in 2033, the enrollment will reach 25 million according to the linear model. All right, now I want to do the exponential model. So on the exponential model, same idea. I take 25, and I'm going to set it equal to. All right, so on the exponential one, let's take this. So I take my 25, and I'm going to set it equal to the exponential formula. So 7.11 times 1.024 to the t. All right, to solve this one, if you're going to solve this one by hand, you're going to have to use logarithms. And since I want to avoid that, I'm just going to use my calculator. And to use my calculator, I'm going to graph the left and graph the right. So I hit y equals. And I already have everything in here. Here's the left right here, 25. Here's the right. And so if I just hit graph, we should see that they cross. So here's the exponential. Here's the 25. And so I hit second, trace. Go down to intersect. All right, now, first, I'm on the line. I do not want to be on the line. So I hit down. And now I'm on the exponential function. That's what I want to be on. So I hit enter. And then it pops me down to the 25. And I want to be on the 25. So I hit enter. Give it a guess. So just hit enter. And it pops right to it. So on this one, T is approximately 53 years. And again, I'm going to add 1965 to it. And if you add 53 to 1965, you're going to get in the year 2018. Right, so the exponential model will predict that enrollment will reach 25 million in 2018.